Before we start, I'd like to give a special thanks to VES and Autodesk for sponsoring and supporting this webinar. For those of you who aren't familiar, the VES is the Visual Effects Society, is a global professional honorary society and the entertainment industry's only organization representing the full breadth of visual effects practitioners. If you'd like to know more or become a member of the VES, check them out at their website, www.visualeffectssociety.com. The formal presentation will take 40 minutes, and keep your questions coming on the chat because there will be a 10-minute Q&A session at the end, hosted by Serena Harris, Annex Pro Director of Sales. We will wrap everything up at 1 p.m. sharp. With that, I will pass it on to Carrie Corlett, Annex Pro founder and CEO. Carrie, you ready to kick it off?
I sure am, Rafaela. Good to see you, and welcome to everybody that's connected to our webinar today. Thank you so much for attending. On behalf of the Visual Effects Society, the Vancouver section, and Annex Pro, I'd like to thank you for attending this special session on taking the mystery out of Bifrost for Maya. The webinar was designed for the VES members, the Vancouver section, and it's one of the many benefits you get from being a VES member. And I want to especially thank the VES for allowing us to open up this webinar to non-members today at no charge. So if you're a member, thanks for attending. And if you're not a member of the VES and you're interested in becoming one or at least checking it out, Google the Visual Effects Society and for more information, or you can absolutely drop me a line at Annex Pro and I'd be happy to discuss it with you. So it's my pleasure to be serving on the board in the Vancouver section. Now, a couple of comments about Annex Pro. That's my day job. My name is Carrie Corlett, as been mentioned. I'm the founder and CEO of Annex Pro. We are celebrating our 37th year in business here as a local Canadian-owned business headquartered in Vancouver. We have offices in Toronto and Montreal and most recently in Burbank, California. What does a value-added reseller do? For those who don't know, we supply tools and solutions, software and hardware for people creating visual effects, animation, post-production, game development, even music and audio production, basically any type of media content created for any type of screen in any sort of format. At Annex Pro, our vision is to enable storytellers to share their dreams with anyone, everywhere. And we do that by becoming the leading reseller of media content creation solutions in the country. We do that by providing products to our customers such as tablets, pen tablets from Wacom, animation software, and from Autodesk, things like Maya, Shotgun, Lenovo workstations, Azo displays, Cumulo storage, Avid post-production, and even finishing solutions like DaVinci Resolve. We represent hundreds of partners, leading industry partners, with the tools that help you take your project from concept art to finishing and really everything in that pipeline in between. Sometimes we get questions, well, why should I buy from a reseller? Isn't everything available online? And it's a great question. Of course, you can buy almost anything online these days, and we all do. But we find in talking to customers that if they're dealing with multiple different vendors, they tend to not get the full value that they could be getting. And so what we do is we provide that added value. Some of these companies are huge. Autodesk, Avid Technologies, Wacom, that sort of thing. It's not really built for the one-on-one conversations. That's where a good reseller can really bridge that gap, and we can help you with a multitude of different solutions through a single point of contact. So no project's too large, no project is too small, and no technical issue, by the way, is too small. If you're roadblocked, if you have artists that are struggling in some way and you're not currently an Annex Pro customer, by all means contact us, annexpro.com. We'd be happy to help you out with any future project you might be considering or anything that might be preventing you from working efficiently now. The consultation is no charge, it's free. We're happy to chat and learn more about your business and how we can help you. I just want to give a special thank you to all our customers that may be on the line right at the moment. Thank you very much for supporting Annex Pro. As you know, we're a locally owned Canadian business with offices across the country. Thank you for buying local and for supporting fellow Canadians. And it's our pleasure to be supporting you throughout these difficult times, especially with COVID the last greater part of this year. So thank you so much for continuing to do that. Now, if you're on this webinar, you're probably already a Maya user, and you might already be using Bifrost. But based on conversations we've had with customers, I'm going to go out on a limb and say that you might not be getting the full goodness from Bifrost. And that's the reason we created this webinar with the VES, is to help our Maya customers get a lot more value from their investment in Autodesk software. So with that, I would like to warmly welcome Scott Eade. Scott is a technical specialist with Autodesk. He happens to live in Vancouver, so if you don't know Scott, he's a great guy to get to know. Contact me or Annex Pro and we can absolutely get you connected. He is a resource that we use with our customers to really add that extra value. So what you see today is available to you if you're a studio in Vancouver or anywhere in the country. He happens to live in Vancouver, as I mentioned. He's an all-round great guy, and he is going to help us take the mystery out of Bifrost for Maya today. So Scott, you have the floor.
Awesome, thanks, Kerry. I'm gonna go ahead and share my screen here, a little presentation to show everyone. So let's go ahead and I'm going to stop somebody else's screen share. Thank you for that. And switch this over. All right, got the Autodesk full screen showing for everyone. Yes, as Kerry said, that's my name. And flattery will get you everywhere, I suppose. Thank you, Kerry. My name is Scott Eade, and I do have a bio up there on the main page, I believe. So if anybody didn't see it, I'll do a little intro. I'm here representing Autodesk as a technical specialist in the media and entertainment division. I started at Autodesk actually earlier this year, so I'm somewhat of a rookie on a team of technical specialists that actually cover the entire world, but in this case, my team covers most of North America. And we specialize in animation, film, VFX, and games. My previous role was here at MPC Vancouver for almost 10 years as the head of previs and layout. And prior to that, I was fortunate enough to be involved with projects down at Weta Digital, Avatar, and Tintin. I started my career long ago, but maybe not so long ago, in early 2000s, going through various roles, modeling, lighting, compositing. But my main focus over the majority of my career has been through layout and animation. As Kerry said, I am based in Vancouver, and with the intention to have more of a presence here locally on the West Coast. So feel free, contact Annex Pro if you want to contact. My email is there. Reach out if you're needing anything, needing some help, pointers, etc. And if I can't help, I'm surely going to redirect you to the appropriate people. And you can also find me on LinkedIn as well, which is where you can contact me through as well. I do have to put up our safe harbor statement. I may make statements regarding planned or future development efforts, and realistically purchasing decisions should not be made based on the reliance of those statements. So what we're here for is obviously explaining what Bifrost is. And in short form, if I were to try to explain it to you in a nutshell, using the Bifrost visual programming environment, we can automate complex processes and generate assets without writing a single line of code. So essentially a data flow graph with the data flowing left to right along connections between ports and nodes. So Bifrost is a tool to accelerate almost every aspect of 3D production, and with added ready-to-use effects right out of the box. Where did it come from, or the history, let's say? Phase one is something that most people are familiar with in Maya today. Naiad, back in 2013, Naiad and Exotic Matter was acquired by Autodesk, along with the principal developer, Marcus Nordenstam, who is currently still on board at Autodesk as Bifrost's senior product manager. Bifrost then shipped in 2015 with Maya, and obviously you have it in Max. The second phase is the content creation phase, which is more comprehensive and in line with what we refer to as the Bifrost extension, which is decoupled from Maya, a separate installer, a separate beta program altogether. So what is Bifrost seeking to do? And realistically, why would I even care? Well, the end goal is really to deliver a procedural framework for artists, TDs, and developers to author tools and workflows that are fast, scalable, and portable. The content is encapsulated into the Bifrost node graphs, which can then be inserted into any 3D scene, including Maya's DG, but not limited to just Maya's DG. It's also a powerful JIT compiler, and it's paired with a next generation data model, which increases performance. And to be honest, it's needed. You know, not to state the obvious, Maya is getting old. It does have its downsides as far as speed. I think it was released back in 1998 with some other softwares, including I think Unreal was 1998 as well. You've got a lot of these softwares are starting to age and show that age. So this is to assist in a lot of that in speeding up performance. The bottom one there, adaptive solving, you see a little picture on the right, included in a lot of the Bifrost simulations is this adaptive solving feature, you know, giving you less memory issues or less disk space, faster solving, creating more detail closer to camera, less detail further away. So we start in Bifrost essentially by working in this single shareable visual programming graph, as I've shown you, with nodes that range from simple to very complex operations. And these operations are being reduced down to portable, reusable compounds. The example shown here has been broken down into its individual processes. On the top, you see the whole graph, and down below is kind of what has been broken out and what this graph is trying to achieve. You could see scattering of the snowflakes based on the normals of a grid plane, randomized rotation of the snowflakes, offsetting positions, and then somewhat reducing the instances to only what is seen through the lens. And artists put this together to basically practice with Bifrost how you would achieve an environment build, or basically a shot, this wintry landscape effectively created through Bifrost and shown here. So I touched on quickly on compounds, or I mentioned compounds. This is a powerful component of Bifrost, and this use of compounds refer to nodes that contain subgraphs of other nodes, or even other compounds for that matter. And the code for these operations can be exposed and viewed. And these can then be published and shared with others, like altered, republished, or stay referenced in your scene for that matter. And so then we can rapidly prototype and create these production-ready, reusable libraries of features, tools, setups, effects, and more. And Bifrost actually does come packaged with a large number of ready-to-use effects in the Bifrost browser right now. So one can import an example graph and play back immediately through the Maya viewport, or render it out for that matter. And everything is supported in the viewport right now. So the viewport and Arnold parity isn't exact, but it is fairly good. You're able to see those simulations through the viewport and render them out if you choose through Arnold or whichever you're choosing to. So an artist can bring these in, or TD for that matter, use these compounds, make small iterations, small alterations, as the example with this torch. And those alterations can then be, again, published, reused, or implemented in the scene quite easily. And realistically, it's not taking too much time or a huge amount of resource. This is one Maya generalist, not an effects TD, at the Mill in LA, who output 35 smoke trail shots in approximately 2 weeks. So this artist had never used Bifrost before, received a little training on site from Autodesk as back in the day, the documentation was not yet available. And another example of expanding its use, and this is again the Mill, where with some development efforts used Bifrost and implemented a means of running it inside Houdini. In this example, they were reading the JSON file back and forth. And again, a little bit of overhead in development there, but opening up kind of possibilities of what is achievable with Bifrost. So we can look at Bifrost compounds and releases and usable content as a collection of packs, so to speak. And each pack is by no means completely isolated here. There is overlap in all the functioning compounds and releases. Effectively, though, we started with the core pack. The core pack is completed in the UI core functions, including file I/O, diagnostic tools, some geo creation, and things like that. We then implemented the effects pack, and I'll touch on each one of these. The third one here, the world pack, which includes things like scattering tools, which would cater to simpler workflows of large asset distribution through user-friendly compounds. And this is still in process. It's highlighted green here as it's still in development. There is a good amount of functionality available right now out of the box from a world building standpoint. And I'll show you some of those examples shortly here. But it still is not complete, let's say. The last, which is still to come, would be the character pack. And I've highlighted it here orange, being that it's still not there. But again, there are examples and people who have already gone ahead with using Bifrost and what it has already contained in it to develop things for specific examples. Let's say IK rigs, for example. So in the effects pack, starting in that section of things, we basically have 4 different categories. First here, obviously, you can see particles. So my artists and generalists can work with live effects elements, making simple changes without involving FXTDs or involving FXTDs for that matter. So this example is just showing the Bifrost output from, the particle output from Bifrost. Second, we have the arrow solvers, which allows you to create natural looking smoke, mist, and other gases. Third would be the Bifrost combustion solvers. So there's a lot of different features here that may differ from other existing solvers in other 3D graphics. One of those is the use of real world fuels and their physical properties. The introduction of physically validated models for soot formation and oxidization. There's radiative heating and also a condensation model built into. So quite a robust combustion solver. The last in the effects pack is what's called the MPM solver. That stands for the material point method. MPM is a technique used to simulate the behavior of multi-phase materials and other materials modeled as a continuous mass or body. Autodesk teamed up with Jixi Effects, which is the founding members of the original MPM research team, and developed a production-ready MPM solver directly in Bifrost. So MPM can handle complex geometries. So this is suitable for large deformation problems. It's a physically based multi-solver, which makes it extremely powerful in interactions with other materials. The solver allows snow, sand, and cloth to come together in one simulation. And as you see in the top left here, and on the bottom, actually the bottom right is showing an avalanche with the cloth tents. And one that's kind of out of the, let's say, effects pack category, but should be mentioned as it's good to note its use with something like MPM fibers. It becomes extremely powerful in applying dynamics to materials that consist of individual strands. So this would be a good candidate for something like hair or fur simulation. Those strands can interact with each other, individually break apart. And if you haven't heard of strands before, the name comes from actually soft-homage ice. They're basically geometry comprised of curves. And strands applications are seen in examples like the braided hair in the top left here, or fuzz and fur applications. The example in the top right is actually online. It's Autodesk Matt Chan giving a Bifrost tutorial on applying that to a character, which is available and good to check out. Additionally, the volume scope diagnostic tool in Bifrost, which visualizes volume flow in these colorful strands as shown below. So here you have another example of that volume scope, and you may have seen this example before, but this is how it was achieved. Taking the strands from what is a wind passing over the vehicle, we populated those strands with instances of chains. And you get this massive chain link render, which has been provided in other examples. This was actually done by Jonah Friedman, who's one of our developers for Bifrost in and around strands as well. So in the next category we had out of the packs, we had the world building. So we move into this area of what is still, again, what is in development, but a lot of stuff already there, components already available for set dressing, scene assembly, level building, and so on. You've layout, animation, and environment artists will be able to work procedurally with much larger numbers of instances. You can create volume terrain or mesh terrain, things like that, and procedural generation of the vegetation or grass and rocks, or even non-organic, let's say buildings or bridges and fences and things like that to come. This is an example of ray casting in Bifrost to project points down onto geometry to effectively define where any of the trees will go on my geometry, which is extremely powerful. You can use the effect of maybe where the sun is casting down, or use multiple points of casting down onto your geometry to get pretty good realistic effects of where, let's say in this case, trees would reside on a mountainside. Additionally, if you haven't seen the Vision Series presentation already, there's one called Lights, Cameras, Effects, and exploring what's possible with Bifrost. And that's available online. Again, Jonah Friedman, who I mentioned, a developer for Bifrost, he's actually the Bifrost product owner, or one of, goes through creating this snowy mountaintop. That's an interesting watch for sure, if you haven't seen that already. And so also what we want to include in it, and what actually some people have already started creating in a basic level, is a system, an L system for the growth processes of plants. So plant development, morphology of organisms, and other things to basically generate these things all in Bifrost to then populate in Bifrost. There's also the modeling operations that we can take into account, and more to come as well. But things that we're seeing right now are basically helping regenerate or fix geometry and any problem realistically in what would be potentially scan geometry or models that you're needing to fix up. Like it states here, non-manifold geometry, faces with holes, non-planar faces, faces with zero area, or edges with zero length. Effectively, we can use Bifrost, link it up to Maya, and go through the process of, in this case, converting it to a volume, remeshing, and then retopologizing. I also have the scattering and constraining of assets, which we can use through Bifrost. And this is a case example of plugging this into the Maya DG and working with Bifrost ocean simulation to scatter this ocean debris, in this case, just these boxes. And we're using that to constrain to the surface. And it's actually the rivet option in Maya, which is a UV pin option. So you still have control of more manipulation of where these objects go, not only from a scatter point in Bifrost, but then over and above within Maya to affect basically all of the transformation values and adding more atop of what you've already done to place them. And so the last one in there, like I said, which is still in development and more to come, is the character pack. And there has been, as I mentioned, some work already done in this area in relation to IK rigs. This is a case of a product called Mimic, which is a free open source plugin for Maya. And it comes from the office of the CTO, which is the program called Octo. And that allows you to simulate, program, and control the 6 axes of industrial robots through IK. So you can use Mimic to generate programs without writing any code. Typically, generating this type of routine for a robot like this can be very manual and laborious. And so out there in the community, there are a lot of resources, and those resources are growing. You have the area, Bifrost area, for anything to do with Bifrost, the help on the beta. If you don't have the beta already, and if you're interested in that, it's something that you can request to be on. You can download the Rebel Pack. The Rebel Pack is essentially extra compounds that the development team for Bifrost releases over and above what comes with Bifrost. You have the Bifrost forum, and essentially another area where you can basically upload your own graphs or compounds and download other people's, a sharing area, so to speak. Sorry, my dog is snoring behind me. It's quite embarrassing. If I could recommend something, if you wanted to check out an article over and above this, something to take away, this is an article that sheds some light on the beginnings and progression of what Bifrost is today. It's called A Bifrost Journey, and it's an interesting read. I can actually copy and paste potentially the link for this later in the chat if you can't see the one up there, or grab the one up there. Cool. And the last little bit, obviously a lot of people ask, and the question comes up, how much extra is Bifrost? And the fun thing about it is it's absolutely free. A subscription of Maya covers Bifrost on up to 4 computers at the same time. So that's 1 running on the DCC, and the potential of 3 running the Bifrost command. If you have the collection subscription, you're entitled to run Bifrost command on up to 15 computers at the same time. So really, really neat to just be able to kind of bring it in on your own time if you'd like, and play with it. So with that, I'm going to actually switch over and just show you some examples of what is achievable in Bifrost. Do a quick time check here, 12:30, cool. Awesome, so opening up the Bifrost graph here, I'm just going to hide the outliner for a minute. I need to create a graph, and effectively it comes in empty. I have the option of opening up, again, the Bifrost browser, and in here you'll see a lot of things that are already there that effectively you can just bring in and test or change on your to your own design if you'd like. So you can see that when I create a graph itself, try and get my outliner back here, sorry, a little management. The Bifrost graph is created in my outliner. And just to show you some basic level things, I have here somewhere an alembic file. So this is a almost 9 gig alembic file, let's say 8, just to be round it down. So it's quite a large alembic file on disk, and it takes some time. When I just do this through either import or through my cache import, it takes almost a minute. For me, it's about 40 seconds approximately. Now I'm running on a small laptop. This is a Razer Blade 15. It's only about 16 gigs of RAM, but I am leveraging some things by using an NVIDIA GeForce RTX graphics card, which for some instances, not loading, but for some instances is beneficial here. So again, it takes almost about a minute to import it that way. If I go into Bifrost and simply tab, I can navigate to all the functions or nodes and compounds that are available with Bifrost. Just move this so it doesn't conflict with that output. So you can see here I have my core compounds and nodes, diagnostic things. I've got things for file, geometry read and write, Down here, simulation. So this is where I find my arrow, MPM, things like that. If I have my own user compounds, I can also find extra things in there. So this changes as you add more compounds to your own library. Now, in this case, I want to import that alembic. I don't remember what the name of it's called, so let me just start typing alembic into the field. How would I type it correctly? That will help. And so it feeds back to me what options I have for alembic. And in this case, I want to read an alembic. I want to choose the file that I'm looking for. In this case, I believe I have it on my desktop. There it is. And so I load that in there. And again, like I mentioned, let's just reduce this a bit. Like I mentioned, the load time for this in regular time is about 40 seconds. And with Bifrost, it just loads immediately. I almost can't really time that as to how fast that loads. Now, in fact, this does have animation on it. And right now it's not playing back because it's just reading it in as a single frame. Oops, extend that out a bit. So it's just reading that in as a single frame. Now, what I need to do is effectively add in a time into the frame rate here. And I can go search for that. Or effectively what I can do as well with a lot of these compounds, and this is available in Bifrost 2100, is right click on it. I go down to create node and it'll feed back to me what options I have to input that, what is most relevant for that port. And in this case, I want to feed back time. And now when I go through this, I can see that that scrubs through. And scrubs through not bad. I mean, I'm not going to get 24 frames per second with that, but I can see the motion of that by scrubbing back and forth quite easy. Now, this is a quite heavy building. This is about, I think it was something like 800,000 polys. It's about 20,000 objects. So it is quite heavy. But effectively what I want to do is I want to leverage some of the scattering tools. So in this case, what I want to do is scatter this atop of a grid plane. So let me create a polygon primitive plane. So just got to remember to do all these things, right? There we go. So let's do a plane somewhere around 10 by 10. So you're talking about, what is that? 11 by 11 vertices. So 121 points here that I can scatter on top. If I simply am just using, and again, I can't remember the name, so let's just say, let's type in instance. So I want to set instance geometry. So effectively, I want to take the mesh and plug that into the points of the set instance geometry. And I'm going to plug this into my output. Give it a second, fingers crossed. Oh, come on. Oh, you know what I'm doing? Excuse me. I just did a very bad mistake here. So let's just cut this for a second. I'm going back into here. Cut that. And I just did the wrong thing. So I've got my geoplane back on the geoplane. So I'm going to drag and drop my geoplane in here. And that will be the points in which I want to scatter my building in. The building itself is actually the instance geometry, excuse me. So let's plug that into instance geometries here. Reset my output because it thinks I've done bad. And there you go. So I've got all of those vertices with the buildings affixed to it. And still I can scrub through, and it's almost, you know, no delay in that time to actually scrub through those things. I can actually add as well onto this something like, let's say, scale. Let's just see what I've got in the way of scale. So I can set point scale. Let's not use that one. Sorry. Let's do that again. So I can set random point scale. Let's use that one. So this effectively allow me to input my instances with a min and max size value and plug that back in there. So that's giving me a option of min size of 0.5 to a max size of about 1.5. And I've got a little F curve here for the scale distribution. I can change that and say, well, hey, I want a little bit more distribution of the larger size, or a less distribution of the larger size, and more finite or more of the smaller scale distributed here. There's another one called, is it randomize aim and up, which is going to effectively work for me to output the rotation values and kind of, you know, distribute those with some randomized rotation values here. And I can do everything X, Y, Z. This is, in this case, just using Y because we're effectively on a plane. So still, I mean, that's kind of distributed on vertices. It's not extremely that, you know, nice unless I had a, you know, just a grid plane for distributing, you know, maybe a city or something like that. And effectively, maybe I want to scatter this a little bit more. So let's type in scatter and effectively use this scatter points to generate that. So let's plug my geometry into there and use those points as where my geometry goes. So you can see here, I can effectively change how many points are on that surface, up the value. Again, I can go back in, change the scale, change the randomization here, and you know, see all of that live in scene. This is viewport as well. As long as this doesn't break down on me and I don't lose the little tab, which I did. Let's go up here and do it this way. Wait for Arnold to load up here. I can show you it's still quite fast with Arnold playing back. And I'll give it a second here because I don't know how much time we have left. I want to show you another example. All right. And so you're seeing here, you know, effectively moving around within my scene. I'm moving quite quickly here, and I'm actually not even sure whether or not I'm still plugging away at my CPU. So let's just see under render settings, switch this up and leverage what could be something a little bit stronger here. So let's switch to GPU. So now you're seeing my GPU is actually providing me with a far faster preview of what I'm seeing here. And obviously playing through it, scrubbing, I get that animation playback. Don't fail me now. All right. All right, there you go. Yeah, so it's kind of cool, and you can see that live. You can also play that through Arnold in the viewport. It's just a little tab that's popping up is popping in behind where the presentation is currently going. So I can't get that right now. I apologize. So let's shut that down. So another example here, again with 1237. Let's take a look at something built up a little bit more. So in this case here, and again, I'm not going with any effects examples. As you can see, this is more of a non-effects related example. These examples are non-effects related, sorry. And in this case, I have a pre-built graph here. And to explain this a little bit further, this is the exact same things as I had before, set random point scale. I've got to randomize aim and up, which is my rotations. I'm setting the instance geometry. I've got to scatter points, which is plugged in, or my terrain is plugged into. So effectively it's this terrain here. And I'm actually plugging in two other pieces here. I've got a pyramid shape, and I've got a render archive. Effectively, this is a Arnold file that's plugged into my instance geometries. And then I'm using a preview geometry as a pyramid. So effectively in scene, and actually I still have that open, effectively in scene here, let's go turn that on. I've got a pyramid reflecting this tree. So this would be my rendered tree, and this is my proxy geo, and then a cube and a prism here. And that is effectively what I have in my scene for distribution. So let's go back. And I've done that 3 times over. So I have a tree here. And if I look in here, I'm using a color set down in the mask. So I'm enabling the mask in the scatter points, and I'm using a color set, which I've effectively stated in, 1 second here, in my color set editor. So I've got tree 1, tree 2, and tree 3. And you'll see that here, tree 1, tree 2, and tree 3 plugged into my scatter points. So effectively you're looking at 3 different trees, all with the exact same inputs, and just effectively outputting slightly different trees here. So I'll just go in and create a backdrop for this so you can kind of see that, what that looks like. So it's effectively these 3 different things plugging into an output with a singular terrain feeding into it. So I can work with Maya. In this case, I can use the, let's close this down, a little more space. I can use the color set editor and use the paint vertex tool and effectively do a bunch of things with this and the color set editor. So in this case, I want to just simply paint the trees, how many trees I want. I can lessen the amount here. I can replace, remove. If I want to just redo that, I can flood it with the black. I can flood it with the white here. Let's go back here and flood it with black. And I can, paint those down. I can choose another tree here and let's say create a dispersed set of trees for different elevations and work with that. I can go back into the Bifrost graph. And let's close that one down and effectively change the distribution on the fly. So let's say I want to scatter points and I want to reduce the amount. I can do that here through the Bifrost graph, reduce that down and change the amounts that I might have in there. I can change the seed distribution as well. What also is handy here, and if I go back into my tool settings and open this back up, is I can effectively add a map to any one of these distributions. So I can take, let's say tree 1, for example, open up the map. Where did you go here? Import a map here. There you go. And navigate to something that I already have for this. So let's say tree distribution map. So let's say I have these varying, let's say elevations of this terrain, and I want to apply that to each one of these. So I can just go in and import those onto the color set. And last one, import this one in here, go with the three-tier kind of distribution of those trees and lay it out that way. And effectively I can go back and say, well, hey, I didn't actually add enough, so let me just add some more and distribute my trees in that way. So that's kind of cool. And the effective thing with this is that each one of these trees is feeding back the render positions. So those render files that are plugged into the set instance geometry right here. So I can go back into my scene and turn on my Arnold render. And again, fingers crossed here. Bit of a pause. Oh, do I already have it open? No. All right, just taking a second to get going. But effectively, these trees then, when I go to render out, and again, let me just make sure I'm leveraging my CPU. Give that a second. And so a little bit slower. These trees are obviously much heavier, but I'm distributing these out for these low-level display kind of trees. Taking a bit, it's a little bit slower actually now. Maybe just the presenting right now is causing a bit of that. But you can see I can get a pretty fast playback of the rendered trees as they're kind of distributed here. So let me just shut that down. And effectively, if I don't like these trees, this is all modular. This is all replaceable. If I have, I'm tired of using these prisms, or I've got an updated tree that I want to plug in here, effectively I can go back to my preview geometries. I've got a pyramid here. And let's say I use a different tree. Let's say I've got this tree here. I could drag it in, disconnect that tree, and add in a new preview geometry. And swap in whatever I want in place of all of those distributed trees. So I can do that for each one of these things. If I've got multiple types of trees, slice that off and just plug this in. And go through and swap each one of these. And then all of a sudden, maybe I want a little bit more detail for placement of camera, or I want to see interaction with an individual tree if I want to animate in and around that object. So that's kind of a distributing. Let me just check again what time we have here. Are we good on time, Raphael?
Yes, we do have a 10-minute Q&A, so you have another 5 minutes.
Awesome, cool. Well, let me show you something completely different. And this is not to do with distribution. Let's just go new scene here. Another thing, and I was talking about modeling and how there's effectively a means to model. If you haven't seen this already, I can bring in, let's just say a cube here and frame that up. And I want that cube to reside in Bifrost here. And I want to convert that into a volume. You can see here that I can effectively create a volume with it. Now there's another compound that's built into here. It's called contour dual marching cubes. And I can plug that into this compound. And this is a very simple graph to create. I have the output of the Bifrost node here. So I can open up the channel box and just create a layer and add that into the layer if I don't want to have a selection there. All right, so then I can effectively select my cube. And as I affect this cube, let's go and select a face and let's go extrude. Who's that? Oop, where'd you go? Let's go. All right. I can effectively model something, whatever. I mean, this is just an option for somebody to kind of play around with. Model something out of this kind of basic shape. Let's go here. And have that volume follow in any direction. I mean, I'm just completely hacking this together so you can see. I can go back into the Bifrost graph editor and change the detail size. So I can effectively go back down to something that's a little closer to, oh, I just went way down, effectively closer to the shape in which I'm trying to achieve. That's way too far. So let's just go 0, 1. And you can see here, I can also take added geometry. And if I've got geometries that aren't together and I need to merge them together, let's just say I create something like a sphere. I'll pull this over here. And you can see this kind of almost touching right here. And I'd say I'm not sure how I'm going to merge my geometries. I can effectively take this and again, just drag it into my Bifrost graph. Here, and let's say merge these two together. Now I need to create a fan in to give me multiple ports and plug that into geometry. And here you can see now I've just created, basically a combination of those two objects. And again, I can still move those around. It'll just update with it. It lags a little bit if your detail is up, but you can crank the detail on this. And effectively, then you could take this object because it's a Bifrost graph and it's recognizable in the node editor. You can effectively do a whole bunch of things. I can plug this back into a Maya piece of geometry, whatever that may be, a dummy piece of geometry, and effectively create something for Maya. Then you have the options of, like I was mentioning before, going through and utilizing the remesh and retopologize tool sets. So that's kind of it for me. Hope those examples kind of were good. That concludes everything that I needed to cover or wanted to cover. Thank you all for your time. I'll pass that on to Serena, and then we'll kind of do some Q&A if that works.
Brilliant. Thank you, Scott. Every time I see it, it blows my mind a little bit more. You could do so much so quickly, and a fantastic presentation. So thank you again. As expected, we have had a fair number of questions, so I'm just going to go straight into that. What would be great, Scott, if we've had a question from Richard Dixon, who's asking about what does it look like, export look like to go from Maya or from Bifrost to other digital content creation tools such as Houdini or Unreal, so that you can go further along in the pipeline steps for FX and lighting and things like that. How does that process work?
The process is not defined as of yet, to be completely honest with you. The ultimate idea here is that Bifrost can be export it out as a JSON file, the Bifrost or Bifrost file itself. The example that I did show was, again, it had a lot of development in and around utilizing it in Houdini. Now, obviously, Houdini is going to have different processes depending on what you're using in Bifrost, whether it be a simulation. It may not have the relevant simulation in another, let's say, Bifrost to Houdini. So effectively, it is what are you trying to emulate? There is no direct conversion right now, but they were able to leverage that back and forth of the JSON files between Houdini and Bifrost. Ultimate goal, and I guess this is probably why I put the safe harbor statement up in the beginning, is to have something there that does effectively work across platforms. Right now, 3ds Max has Bifrost in its beta program. So effectively, they are working up an ability to have the same language, so to speak, in both DCCs. So that is the hope, and moving forward, that would be something that we would love to see happening. Now, take into account that Bifrost command can be run completely separate of Maya altogether. The processes there are contained within Bifrost completely. So I can create a graph, and all of the graphs, for that matter, in the Bifrost browser come into you with no relation to Maya whatsoever. When you bring those in, those are all being created tip to tail in the Bifrost graph. So that is effectively what you could offer other ways of rendering or other ways of using in DCCs. Hopefully that answers your question. Hello, Richard.
Thank you, Scott. I think Daniel Barnes also asked a question which I think was similar, and I think you've answered. So if in the future there are other ways of export, I'm sure Daniel would love to hear about it from the sounds of things. So we'll have to keep that in mind.
Yes.
And I know you can't commit to anything, so we get that. I had one question I had listening to your presentation was you talked about the packs, and some of them are in development and some are still to come. And you also mentioned that Bifrost is free with Maya, so there's no cost for Bifrost. Will we have to pay for those extra packs, or will they just become part of the solution as they become released?
They all come with the release, effectively, yeah. And like I said, the cool thing is you got all those extra ones that are already showing up. So people that are playing around and are like, hey, I want to show you, how I can create a deformed geo based on footsteps or footfalls of a character. There's something already, somebody has something out there already, which will generate that for you. Effectively not sitting there and modeling your terrain down to work with your character. This is something you plug into Bifrost, and it'll read those footfalls in as collisions to your geometry. So all of that stuff is building up. The Rebel pack is extra stuff, but yes, the packs that I was speaking of mainly are the things that will come in as defaults for where we want to get to in Bifrost.
Perfect, that's great news. One other thing that's come up is USD available in Bifrost at the moment?
USD is not available in Bifrost at the moment. And I say that with the caveat that I have not been able to bring in USD into Bifrost at the moment. Now, it's really, I don't have the time to be able to kind of relay to you, because USD is a huge, huge topic in itself, is probably half-hour conversation, or if not more. There is a really good, and again, I'm pointing back to the Vision series, but there is a really good update, and it was just last month, where we updated everyone on the current status of Maya USD. So the USD work that's ongoing with USD in Maya. And I can mention now the beta version of Maya right now has that built into it. You can import, export USD. You have the ability to navigate in the outliner, get details on available attributes and transforms and things like that. So it's building up, but that's very, very short form. Check out that Vision Series 1, because it has a lot of information done by Will Telford, who's an amazing guy. He's awesome at kind of describing either in detail or in layman's terms, whatever, where USD currently is. And it's extremely helpful. I had to go watch it just to kind of get myself up on where we are with it. But short answer, not at the moment. But yes, ideally, this is where USD plays a major role in Maya's kind of usage of massive scene builds, layouts, environments, things like that.
Great, thank you. I think that's a good segue to mention to everyone Autodesk has a wealth of knowledge that's available free of charge, Vision Series being part of that. And actually so much knowledge and information that sometimes it's quite hard to navigate. So if there is anything that you're specifically interested in learning more about, maybe USD is one of those things, just let us know. We'll point you in, we'll send you the links to how to get to that information. The other thing to mention that is if in your studios you have any complex pipeline workflows that you want to discuss in more detail, or you want to do a deeper dive into whether it's Bifrost or even, what's coming in Maya, what's in the beta version, more discussions around USD. Scott is happy to, Scott is happy to have sessions with you that we can set up. And there is also a whole raft of further information behind this presentation that Scott's done that's already available. And again, we can send you that information. And Daniel has asked a question which says, any Easter eggs you want to give away with next release plans or developments?
Yeah, well, I guess I have put up the safe harbor statement, right? But I think the biggest one, and the one I'm excited about, is the one I already just kind of laid, which is that USD is present in the latest beta release of Maya. And unless something horribly goes wrong, and with all of the hype around it, I can see it being soon. But yeah, I mean, again, don't count me on it, and please don't purchase it based on Scott saying USD is going to be there. Yeah.
Great. Okay. So I think I have to say thank you again. If anybody doesn't have Maya and does want to try Bifrost, as Scott said, if you have Maya, Bifrost is free. But if you don't have Maya and you want to try Bifrost, you can download it from the Autodesk website. So there's a free trial available. So again, if you want information about where to find that, email Annex Pro or Scott directly. He left his email address up there at the beginning, or we can put you in touch with Scott, no problem. So I think just to say thank you everyone for joining us today. I hope you got some good nuggets of information. Thank you very much, Scott. I found that really interesting and I learned something new, so that's great. Thank you, of course, to VES for sponsoring this and to my team for organizing it. If you want any further information, you can contact Annex Pro at contact@annexpro.com, or you can contact Scott directly. So I will leave you with the rest of your day and say goodbye. Thank you.